Hi, my name is Katie Taft, and I'm going to be letting y'all know about the physical properties of sand today. Some of the physical properties of sand, silt, and clay are sand is structurally simple, while silt is intermediate between clay and sand, where clay is more structurally complex. Sand is relatively unweathered, physically broken down, free from organic material, and contains particles in various sizes, whereas silt has limited ability to retain particle nutrients. Particles tend to have a spherical shape, and that spherical shape allows them to retain water decently, but also readily allow water to be provided to plants. And then lastly, the physical properties of clay are it's physically colloidal, submicroscopic, and held in suspension in solution. When wet, it's viscous when wet, gelatinous, sticky, and dry. When it's dry, it's hard, packed, and cohesive. It's composed of micelles, which are flat sheet-like plates, and they're laminated into stacks. And then it has very large internal and external surface area and very small internal and external pores.
Hi, my name is Christina Smith, and I'm showing you guys a little bit of a picture showing the difference between the different physical properties. So as you can see in the sand, in the close-up, the particles are very small and they have kind of like larger spaces between them. And then silt has like a mixture, so like some large, some like very small. And then clay has the smallest particle size. Perfect.
Hi, I'm Riley Boggin. I'm going to be going over the chemical properties of sand, silt, and clay. Sand is relatively inert. It results in little effect on soil chemistry and pH. It has poor nutrients, holding capacity, which would be like the CEC. Silt is an intermediate chemical properties between sand and clay. It has medium inertness, and which means that it has some effect on soil chemistry and pH. It has good nutrient holding capacity, and then it also does not flocculate like clay does, but it does have medium cation exchange capacity. This is the nutrient holding capacity. Clay has very complex and a negative charge. It's very high in CEC, which means that nutrient holding capacity. The charge allows flocculation, and then it also allows deflocculation, which means for it to spread out. Calcium promotes flocculation of soil particles, good soil structure. Sodium promotes deflocculation of soil particles and poor soil structure.
Hi, my name is Wesley Capo. I'm going to talk about the pore space properties between sand, silt, and clay. So first, let's talk about the sand pore space property. It has less total pore space. It's more large in macropores, and it has fewer smaller capillary pores. This causes increased aeration, increased drainage, decreased water, and holding capacity. So for silt, the pore space properties, it has a small pore space, and it's more difficult to drain compared to sand. Now for the clay pore space properties, it has greater total pore space. It's more smaller pores than larger pores in it. So some of the clay's qualities because of that include decreased aeration, air holding capacity, decreased drainage, increased water holding capacity, and increased fertility.
And lastly, the typical agricultural soil is 20% clay, 40% sand, and 40% silt. So ideally this would make the best agricultural soil. It creates a balance between aeration, drainage, water, holding capacity, and fertility.
This has been Sand, Silt, and Clay. We're Group 40 and Gig 'em.
Yeah!